Welcome grade 12s, and today what we're going to do, well, we're finished with our curriculum, yay, we're so excited, but now we need to do revision. Okay, so today what we're going to be doing is we're going to be revising mechanics. That's both grade 11 and grade 12 mechanics. Remember, from grade 11 it's Newton's laws 1, 2, 3, and Newton's law of universal gravitation, which they're going to ask very, very specifically, so it's important that you learn those. And then, of course, there's, in grade 12, we've got vertical projectile motion, we've got momentum and impulse, and we've got work, power, and energy. Now, in an hour, there's not much, I can't get through all of that, so we're going to see how much we can get through. We're going to start with vertical projectile motion, and today, you guys are going to do a lot of work, so we need to see how much you've actually learned this year. So, let's just dive into the first question. And sometimes I'm going to do the answers straight away with you, and sometimes I'm going to let you do some, okay? So, they tell you ball A is projected vertically upwards from the ground near a tall building with a speed of 30 meters per second. Ignore the effects of air friction. Now, the very first question here I want to do with you, I'm not going to give you time for the first one, but the first one says, what is meant by a projectile? Now, this is quite important because a projectile and an object in free fall are actually very similar. Okay, now an object that's considered to be a projectile, so when we look at question 1.1, a projectile is simply an object, okay, and it can be anything, which only experiences, which only has, it's a better way to put it this way, which only has the force of gravity acting on it. Okay, that's really important that we get this, okay? So a projectile only has the force of gravity acting on it. Now, please be careful here, because when we hear the word projectile, we tend to think of things that have been thrown or projected. It's not what we're talking about. Here, we really are just talking, and it can be dropped, it can be anything. As long as it's free falling, it's called a projectile, okay? Great. Now, here's the first question I want you to do. Okay, so you're going to get 3 minutes, and what I want you to do is calculate the total time that the ball A will be in the air, and, okay, you might not get through all of those in 3 minutes, we'll see how it goes, the distance traveled by the ball during the last second of its fall. Okay, I'll tell you what we'll do. Let's split this up, because if you get 1.2.1 wrong, you're going to get the next one wrong. So, I'm giving you 2 minutes, and all you're doing for me for now is this one. Okay, you got 2 minutes, and you're going to calculate the total time that ball A will be in the air. Okay, and your time starts now. So, grade 12s, how many of you got that? Okay, 2 seconds, you should have got it quite easily. 2 seconds, 2 minutes, my goodness. Now, what I'll need you to check, and this is really important for me, is, and I did this deliberately, is I'd love to know, I wish I could see hands, how many of you actually drew a diagram before you try to answer this question? Because without a diagram, it's actually really, really difficult. Okay, and I draw a diagram. If you could see my notes on how I answered this, you'd see the diagram that I drew. So now, if we go back to the question, it tells you that a ball is projected vertically upwards from the ground near a tall building with a speed of 30 meters per second. So if we're going to draw a diagram, this is what they're saying to us, okay? There's my ball. It's being projected upwards at 30 meters per second near a tall building. Now, the tall building actually is irrelevant for this first part, but it doesn't matter. Then they say to you that, well, that's all they give you, and then they say to you, how long does it take for the ball to reach the ground again? This can be done in lots and lots of ways, but I want to encourage you to do it in one step. That's why it's only worth 4 marks, because you can do it in one step. Very first thing you have to do is decide on a direction being positive. I always like to take original direction as positive, so up is positive. That means the ball's going to go up with a positive 30. Now here's the trick with this one. Remember, it's going to go up and then it's going to come back down, and because it ends where it starts, okay, so now let me just write this in. I know initial velocity is 30. Because it ends where it starts, here's the trick. My final velocity is minus 30, okay? It's going to go at exactly the same velocity, but in the opposite direction. Same speed, different direction, okay? So it's minus 30 because it's coming down at 30 meters per second. But here's the next trick, and this is why they asked you the first question. What is the acceleration? Well, it's gravity. Gravity always acts down. So it's 9,8 meters per second, okay? And what I want is time. Now I look at that and I go, well, actually, I've got quite a bit of stuff. So from here, I can put this straight into this equation of the equations of motion. This is why having an information sheet is so important, because I can put it straight into here. That's minus 30. That's 30. And here, it's minus 9,8, and we don't know time. Okay, so now the mass thing, the 30 goes over, so we have minus 60 divided by 9,8 minus 9,8, and my time is now 6,12 seconds. Guys, if you get a negative time here, you will have made a mistake. You cannot have a negative time because time can't go backwards. Okay, good. Now, keep that time in mind, because now they want to know, calculate the distance traveled by the ball during the last second of its fall. That's quite important, okay? I really want you to try to think this through. So I'm going to give you 2 minutes again, and your time starts now. All right, so grade 12s, how many of you put your pens on the desk and went, I can't do this? It's all right. Deep breaths. So we go back to our diagram. Now what they're asking you for is they're saying, well, if we looked at the last second of its fall, what is that displacement? Okay, so now you've got to say to yourselves, in that last second, I know that the velocity that it hits the ground with is minus 30. So now you go, so we think through this, and we go, well, if I knew this velocity over there, then I could work this out. And then you say to yourself, well, can I work that velocity out? Of course I can, because for the first, before we get to that last second, this is what I know. Okay, no, it's not what I wanted to do. This is what I know. My initial velocity is 30. Okay, I'm going to leave VF for now. A is still minus 9,8. That's not going to have changed. But the last second means that it gets to the velocity just before that last second at 5,12 seconds. Oh, look at that. I can find VF. So watch what we're going to do. So VF equals VI plus A delta T. So this is 30. This is minus 9,8 times 5,12. Sorry. And that gives me minus 20,176. I'm going to keep all the decimals for now. So what this means is when we look at the motion, here's the last second of the motion. Over here, it's going at minus 20,176. Over here, it's going minus 30. So that's now my initial velocity. That's now my final. That's time, and I want delta y. Oh, look at that. And I know, even better, that A is minus 9,8. So actually, I've got lots of information. The reason why I wanted VI is because even if I try to use this equation, I would still need to know VI. Okay, either way, you can actually use anything at this point. But to me, I don't like manipulating equations if I can at all help it. So VI delta T, not V delta T squared. Okay, it's VI delta T plus a half A delta T squared. Apparently, I've forgotten how to write. So that's minus 20,176 times 1 plus a half times 9,8 times 1 squared. And of course, I put that into my calculator. And it's minus 25,08. But the question was, calculate the distance. Distance is a scalar. Okay, so distance, that you can never give me a scalar as a negative. Okay, so you're going to say to me that therefore the distance that it falls is 25,08 meters. Yay! We're so happy. Oh, but now we get to the fun question. I can hear the groans. It's all right. So now it says to you, 2 seconds after ball A is projected upwards, ball B is thrown vertically upwards from the roof of the same building. The roof of the building is 50 meters above the ground. Both balls reach the ground at the same time. So what they're saying to you is ball A goes up and comes down, and that happens at 6,12 seconds. 2 seconds afterwards, ball B is thrown up and then comes and hits the ground. But they hit the ground at the same time. So time is important now, okay? And what they want to know is the speed of ball B with which it's projected. And it's speed, so you don't actually need direction, but it's the speed at which the ball's projected, okay? Now, I know you've already done a lot, okay? So we're going to go a little bit longer now. So what I want you to do, see if you can do this, and I'm going to give you 2 minutes, and your time's going to start now. Grade 12s, I really hope some of you got the hint that I was trying to tell you, because this time was really important. They said to you in the question that ball B is thrown 2 seconds after ball A and lands at the same time. What they're telling you, and this is the important part, that the time it takes for ball B to hit the ground is going to be 6,12 minus 2. This was the important thing, 4,12 seconds. So if we now go and we want to answer the question, what I know is it's been thrown up with something. I don't know final velocity, so there's nothing I can do there. I know A is minus 9,8. I can't change that. Okay, it's what I chose at the beginning. T is 4,12 seconds. Delta Y, now listen here, is minus 50, because it goes below where it starts. And if it goes below where it started, it's negative because that's down. So now we look at this and we go, well, we want VI. So let's use this equation. Delta Y equals VI delta T plus a half A delta T squared. That's minus 50. We want VI. Okay. And this is minus 9,8. And this is 4,12. Now, just to save some time, grade 12s, because I know you need a break and your brains are a little fried right now, I'm not going to show you all the maths, but what you get is 8,05 meters per second. The question was, what speed is it thrown at? I don't need a direction. Okay, so that's fine. I can leave it as it is. Big deep breaths. They're not as bad as it sounds. Okay, grade 12. So I'm going to let you take a little break, and then when we come back, I've got one little more section of this, one more question in this one to do, and then we're going to move on to something which hopefully you'll find a little bit easier. Okay, so take a short break, and we'll be back in a second. Welcome back, grade 12s. Ready to tackle the last one of that question? This is one of those things that you probably guaranteed to get a sketch graph of some sort. And they say to you, sketch velocity time graphs for the motion of both balls A and B, so it's the same question, on the same set of axes. Clearly label the graphs for A and B respectively. Very, very important. Then you have to indicate time taken for both balls to reach the ground, time taken for ball A to reach its maximum height. Okay? Now, I'm going to give you, because I want to make sure you get this right, I'm going to give you 2 minutes, and your time starts now. All right, grade 12s, let's see how you did. Now, it's a velocity time graph. All right, first of all, we know that it can be both negative and positive. In fact, we've got negative and positive values on in our answers. So we use a ruler. Oh, no, we don't put extra ones in because we can. Okay, so there's my set of axes. Okay, now please remember that you have to label them. So this is delta t. Okay, and this is v meters per second. Now, first thing is if we think of what's happening with ball A is thrown down or thrown into the air, sorry, at 30 meters per second, then goes then reaches top of height, comes back down, but it's projectile motion, it's under free fall, so the only acceleration it experiences is 9.8 meters per second. That means when you draw this one for me, okay, this has to be a straight line that does this. Okay, now writing everything we know about ball A. So it was thrown up at 30. The bottom part here goes to minus 30. Okay, they wanted to know what time it reaches the ground. So that's 6,12. I'm just making up numbers as I go along because I can. 6,12 seconds. So we'll find now, they asked what was the maximum height when it gets to the top. That's halfway through its motion, which means it's half of that. It's 3,06, and this is ball A. Fine, we're happy. Ball B. Now, ball B starts 2 seconds later, hits the ground at the same time. What's important about this ball B? So ball B is going to start 2 seconds later, and I'm hoping you can see it on your screens, is that the line for B must be parallel to the line for A. They experience exactly the same acceleration. So when I go here, it must go at the same time. This here is 2 seconds, all right? And what I know is that it was thrown up, so we're going to just at 8,05, and that's ball B. Okay, that's what your graph should look like. Guys, please be careful, and I see this all the time when I'm marking, is you don't label which is A and which is B, and then I can't give you marks because I don't know what you've done. I don't know if you understand where A is. I don't understand if you understand where B is. Maybe you were sneaky and looked over somebody's shoulder. Okay, we need all the detail. Don't forget label your axes as well. Okay, not so bad. So let's finish with projectile motion and get to acceleration, well, Newton's second law, which of course we all love or not. It depends on how you feel. I love Newton's second law because I think it's easy. So here we go. We have a 5 kilogram mass and a 20 kilogram mass, which are connected by a light inextensible string, which means you can ignore it, which passes over a light frictionless pulley. Yay, no friction there. Initially, the 5 kilogram mass is held stationary on the surface, while the 20 kilogram mass hangs vertically downwards, as shown in the diagram, not drawn to scale. When the stationary 5 kilogram is released, the two masses begin to move. The coefficient, and I'm going to write it here, of kinetic friction between the 5 kilogram mass and the horizontal surface is 0,4. And now they ask you to ignore the effects of air friction. First question, calculate the acceleration of a 20 kilogram mass. So there is your diagram. Okay, I want to know what the acceleration is. Okay, Newton's second law. This one's going to take you a little longer, so I'm going to give you 3 minutes to see how far you get, and those 3 minutes start now. Okay, grade 12s. I'm pretty sure that you're going, no, Tracy, we're not done. I know you're not done. Okay, but let's get going anyway, because I think I could give you another 20 minutes and it wouldn't make a difference for some of you, unfortunately, because you don't even know where to start. So, this is a Newton's second law question. We've got to remember that we're going to have tension on the 5 kilogram going up, tension on the 20 kilogram coming down. The 20 kilogram has Fg coming down, and the 5 kilogram is experiencing friction. So, with this sort of question, the first thing we do, okay, is we need to say, we draw little free body diagrams. So this is the 5 kilogram, and we've got tension going in that direction, and we've got friction going in that direction, and we're happy. Then we have the 20 kilogram, which has Fg, pretend that's an arrow that you could actually read, and Ft goes up, and that's 20 kilograms. Now we need to set up two equations. So F net equals Ma for the 5 kilogram, and we go fine, the 5 kilogram is going to move to the right, so Ft is bigger than friction. But we didn't know friction. But what we do know is that friction, and in this case it's kinetic friction, is mu k times n. And of course, remember that n is going to be equal to Fg. So I'm just going to write this in here so I remember that that's what I'm doing. Okay. Now I substitute in what I know. I don't know Ft. I know mu k, it's 0.4. N we just said was its weight, okay, so that means it's 5 times 9,8, which is then 5a, and this gives me this. Oop, no, not equal. What am I doing? So it's Ft minus 19,6 equal to 5a. I'm going to call that equation 1. Now we look at the 20 kilogram and we do the same thing. All right, so F net equals Ma. This time Fg is bigger than Ft because the 20 kilogram is going to accelerate downwards. So Fg is going to be 20 kilograms times 9,8 minus Ft equals 20a. So that gives me 196 minus Ft equals 20a. Now, grade 12s, in terms of your science is done. That is the science. Now, out of the 5 marks, 3 to 4 marks here. Okay, lots of little bits and pieces, but it's all here. The next mark is being able to solve for A. How you do this is up to you. We actually, in my own school, myself and a colleague teach this very differently. But I tell my learners to always do this, to always add the two equations. So you go Ft minus 19,6 equals to 5a. And then I go 196 minus Ft equal to 20a. The reason why I do this is if I've set the equations up correctly, Ft cancels. That means that now I have 196 minus 19,6, which gives me 176,4, which is equal to 25a. And then to get A on its own, I'm going to go 176 divided by 25, which gives me 7,06 meters per second. Now, I look at that number and go, it's quite high. Okay, it's quite a high acceleration. But when you go back to the diagram, this 5 kilogram is fairly light in comparison to the 20. So it's not, Ft is not going to be very big. All right, so don't stress about it. If I'd got an answer here of greater than 9,8, then I know I've got a problem, okay? But at the moment, we're okay, so don't stress about it. These questions always, what do? Do a free body diagram, set up the two equations, and then solve for A. Obviously, from here, we could ask you to solve Ft. They didn't in this question, which is quite nice. They asked you other things, but shame. I think we're all, that was too much, and I need you to think about this for a little bit, okay? So we're going to take a short break, and then we come back. We've got another question for this, and then we'll tackle a Newton's law of universal gravitation. Okay, so we're going to take a short break, and I'll see you in a couple of minutes. Okay, so grade 12s. We know the acceleration. We're coming back to the question. So now we know the acceleration. Now I've got 2 more questions, and I'm going to ask you to do both of these together. It says, calculate the speed of the 20 kilogram mass as it strikes the ground. Now remember, they were initially stationary. And at what minimum distance from the pulley should the 5 kilogram be placed initially? So the 20 kilogram mass just strikes the ground. Okay? So I want the speed as it strikes the ground and how far the 5 kilogram must be from the pulley. All right, so you've got 2 questions, and I'm giving you 2 minutes, and those 2 minutes start now. All right, grade 12. So how many of you are trying to answer this question by doing all sorts of weird things, like trying to use Newton's second law and all the rest of it, and you're going, no, I don't know how to answer this. Guys, this is an equations of motion question because they told you that initially it's not moving. Then they told you, well, you worked out the acceleration of 7,06 and you know the distance. So if we go down here and we say, fine, let's do this with what we know. VI is 0. They wanted to know what speed it hits the ground with, so VF is what we're looking for. A is the 7,06 that we've just worked out. Delta T we don't know, and delta Y is 6 meters. Now what I've assumed by those values is that down is positive because that's the direction that the 20 is moving in. Okay, so we look at this and we go, well, we want VF and we don't have T, so I'm going to use VF squared equals VI squared plus 2A delta Y. VF is what I'm looking for, so that's 0, and 7,06. That's 6 as well, and we got 80. It's 84,72, which then you square root. So let's take that out. 84,72, which we square root. That's what I'm trying to do, and we get 9,2 meters per second. Great. Now the next question really is so simple, and I think sometimes we get quite bent out of shape over little things. Because now they ask you, how far must the 5 kilogram be from the pulley in order for the 20 kilogram to hit the floor? Well, if the 20 kilogram must go 6 meters, so must the 5. It's the same distance. If the 5 goes less than 6 meters, then the 20 will go less than 6 meters. If the 5 goes more than 6 meters, the 20 won't stop just before the floor. Okay? Or it'll, well, it can't go below the floor, but it's too far. Okay, for it to just reach the floor, it's got to be 6 meters. Okay? All right, so let's get on to this one. This is such a nice question, this particular one. And I chose it because it's unusual in what they've asked. So that's why I did it. Now, it says to us that a person of mass 60 kilograms climbs to the top of a mountain. Silly person, which is 6,000 meters above the ground. This is even more silly. That's 6 kilometers, okay? This is not on my to-do list. It's not on my bucket list, if anyone's wondering. First thing they ask is for you to state Newton's law of universal gravitation in words. This is just like Newton's second law. It's a non-negotiable. You have to know it, all right? And remember, this one says to me that everybody in the universe attracts every other body or object in the universe with a force that is directly proportional to the product of the masses and inversely proportional to the square of the distance between them, okay? Guys, I cannot emphasize enough to you the importance of learning your definitions, okay? I really can't. So, that's a definition. Now, I love this question. Now, it says to you, calculate the difference in the weight of the climber at the top of the mountain and at ground level. You need your information sheets, okay? You need your information sheets. Calculate the difference in the weight of the climber at the top of the mountain and at ground level. It's 6 marks. That means you've got to use 2 equations, okay? And now, I'm going to give you 3 minutes to do it. As you're doing it, what I'm going to do is I'll write, as you're busy, when I give you 3 minutes, I'll write the mass of the Earth and the radius of the Earth on the screen for you to make it a bit easier. But your 3 minutes starts now. All right, grade 12s, let's see how you're doing now. I'm pretty sure some of you go, but Tracy, we're not finished doing the calculations because you probably got the long way around. It's all right. Don't worry about it, grade 12s. the whole purpose of this is sometimes you need to start something for me to be able to show you, well, actually, there's an easier way. The fact that they said a difference in weight actually does make it easier for us, because if we want a difference in weight, we've got to recognize that the further away the climber gets from the surface of the Earth, the smaller his weight's going to be, because that's the force of attraction between the Earth and the climber. So the first thing I'm going to do is say, well, on Earth, on the surface, okay, his weight is Fg. I don't need to use the gravitation universal, I don't need to use the equation for gravitation, okay? So that means it's 60 times 9,8, which is 588 newtons. So that's on the surface of the Earth. Now, on the mountain, now I do have to use Newton's law of universal gravitation, which means the force of attraction is G m1 m2 over r squared. Okay, now I'm just going to change color just because this pen's a little thinner. So remember, G is the universal gravitational constant, which is 6,67 times 10 to the minus 11. Let's make mass 1 the mass of the Earth, because that didn't change, and I gave that to you, 5,98 times 10 to the 24. And, of course, the silly little climber has a mass of 60. Okay, can you tell this is not on my bucket list? Then, the radius of the Earth is 6,38 times 10 to the 6. But now is another 6,000 meters. Okay, so you can either write the 6,000 or you can recognize that it's 6 times 10 to the 3 that you need to add together and square root it. Now, grade 12s, this now becomes a calculator issue. Guys, please do it more than once to double check your answer. Okay, when it gets complicated like this, I worry that you do it once in your calculator and you don't realize you've done a calculator error. But what you get is 586,84 newtons. It's smaller, which we expect. He's further from the center of the Earth. But that wasn't the question. The question is, what is his difference in weight? So we actually need to write that down. So we go, well, his difference, because now we're answering the question, difference in weight is going to be big one, 588, minus little one, 586,84. And that gives me 1,16 newtons. Now, ladies, what that means for us is we'll barely see it on a scale. So I am going to say to you, if you want to go climb up a mountain to look like you've lost some weight, this is not how to do it. Okay, rather go sit in a lift and let the lift go up, down, one of those, can never remember. Okay, what you need to remember here, grade 12s, okay, is if you got some of these wrong, it's all right. Take heart. You get better as you do more questions. The more you practice, the better you get. At this stage, your focusing should be on practicing questions over and over and over again and on learning definitions. Okay, definitions are the easiest marks you have. They're level 1 questions. They're there to help you do better, to pass. The rest, the more you practice, the more questions you do, the better you'll be. Okay, and you'll see there's not much we can ask you. The same questions come up over and over again. It's just about reading the questions and then doing the things like I did in the questions, which I did on all of them, if you noticed. Underlining things, circling things, see what's important, working through it, talking through it in your head, not out loud. Okay, you're not allowed to talk out loud in an exam venue, but practice, practice, practice. Okay, grade 12s? Unfortunately, my time today is done. I know, it goes so quickly, but next time, we're going to revise some organic chemistry. Okay, so I'm excited about that. And, well, I have to say goodbye, so I'll see you again next time.
Siyabangena! Wars and Matrix is back, and better than ever. With catch-up lessons, revision and learning support on more platforms than ever before. There are great support materials on the DBE Cloud. Find us on television and revise 10 subjects. And if you miss something, relax, Ntwana. Go to our YouTube channel or DSTV catch-up. Need help? Check out Vele, our Telegram-based chat platform where teachers are waiting to help you. Prefer WhatsApp? Send questions or voice notes to our Wars and Matrix WhatsApp line. And that's not all. Want to test yourself? Check out the Matric Live app. Hey Matrix 2021, we've got you covered. Confused where to go? Visit the Waza Matrix website at wazamatrix.co.za. Waza Matrix.
Hey South Africa, September means it's time for Siyavula's annual 1 million maths competition, where you can practice maths and science questions online with great prizes for both learners and teachers. It's a chance for you to learn and win. To enter, sign up at siyavula.com and opt into 1 million maths. Good results in maths and science can open the door to a brighter future. So sign up to Siyavula today and join the competition.